All right, so this is very typical. And when you see it lined up like this, it's almost screaming use elimination on me. I mean, I don't have it solved like y equal anything, y equals, or anything like that. This is just, it's all lined up perfectly for elimination. The x's are lined up, the y's are lined up, the constants are lined up. So let's go ahead and do our elimination. Let's start by eliminating the y's because I have opposite signs there already. So I'll multiply this one by 6 and this one by 5. So it's 18x plus 30y equals 42, and 10x minus 30y equals 55. So 28x equals 97 divided by 28. Okay. That doesn't reduce. But it's okay. It's still a good fraction. It's nice. But what I'm not going to do is I'm not going to take 97/28 and substitute it back into one of these equations. That would be insanity. We wouldn't want to do that. So instead, I'll just do elimination again. I'll go back and I'll do a second elimination, this time with the idea of eliminating the x's. So in order to eliminate the x's, I'm going to multiply this by 2 and this by negative 3. Or it could have been negative 2 and positive 3. It doesn't matter. So 6x plus 10y equals 14. Negative 3 gives me negative 6x plus 18y equals negative 33. Yes? So the x's cancel. I get, that's a 10. Okay. 10 and 8, that's 28y equals negative 19. So y equals negative 19/28. So my point of intersection is at xy 97/28. Here's my point of intersection. So, yeah, the answer isn't the prettiest thing on earth, but it's okay. Just not an easy number to work with. Anything else? Today what we're going to do is we're skipping the whole thing on matrices. Okay? We aren't going back and doing row operations and that sort of thing. You'll get into that again when you take more advanced mathematics. You can take entire courses on matrices. Good times. I actually took 4 of them in college. Good times. Well, what we're going to do today, we're just going to look at systems of linear inequalities. And we've already done a little of this, but we're going to get a little more into the systems. Now, in Algebra 2, we extended this into the idea of linear programming. You may remember that section where you did all these story problems and just set up all these equations with all these lines and then find where the points of intersection are. We're not actually going to even go into that. There is a section on that here, but we aren't going to get into actually writing the problems and doing that. We're just going to give you the equations and ask you to find that. So basically the idea here is graph each equation that we're given, find the points of intersection, usually graphically, because we're graphing things. Usually just set up so they get nice points of intersection. And then maybe do something with those points of intersection to maximize or minimize a function. But it's not difficult at all. This is a very typical problem. Sketch a region bounded by the equations find the vertex of the region, each vertex of the region, use those points to find the maximum and minimum values of the function f of x, y equals 5x plus 3y. So again, we start by doing the graphing of all the inequalities. Now, that's a lovely picture on page 86. The 80s called, they want their fashion back. Okay, just like the Radio Shack, which was a really funny commercial, by the way. If you recognized half the stuff going on in the 80s, you guys probably were like, watch that commercial and were like, what? What? I was like, I know that. I remember that. I'm old. Okay. Oh, I was happy and then I was disappointed at the same time because it made me old. Okay. So we have to graph our lines. Y is less than 5. Now, a y equals equation. Is that going to be a horizontal line or a vertical line? If I graph y equals 5, am I going to get a line going across this way or a line going up and down? Cross, because y is the height. It's a constant height. So y equals 5 would be a line at 5. So I'm going to go ahead and actually do these, but I'm going to change the color so that they're not black along with the background. So let's do, what should we do? I'm thinking like a bright neon green. There we go. Okay. Okay. So y is less than or equal to 5. So 1, 2, 3, 4, 5. That's where we go. That's my line y equals 5. Again, that's a nice point right there. That's fine. We've got that one. X and less than would be below. Okay, so just a little shading below to let me know which side I'm going to be on. X is less than or equal to 3. So that didn't help me much. 4, 5. There we go. X is less than or equal to 3. So there's x equals 3. And less than would be to the left. So we've got a point of intersection here at 5, 3. Now the other lines. Y plus 2x is greater than 0. Okay. Y plus 2x is greater than 0. I have to graph that line. Well, the line I'm going to get is y plus 2x equals 0 when I graph the line. The inequality we'll get to in a second. So that's y equals negative 2x, right? So that is an intercept at 0, 0. And a slope of negative 2, so that's up 2, left 1. So some points on that line might be here, and here, and here, there, there, and there, and there. So that's kind of where that line's going to be. It is going to be a dashed line. So we pull out the old dashed line. Bring that in there. Okay. And by the way, I do have a point of intersection down here at 3, negative 1, 2, 3, 4, 5, 6. Point of intersection. For graphing inequality, I can't test 0, 0 because it goes through 0, 0, right? I can't test 0, 0, can I? So you have to test a different point. Let's test point 5, 3. 5 plus 2 times 3 is greater than 0. Yes. Oh, it is backwards, isn't it? I've been doing that lately. I don't know why. Again, old age. Must be the 80s. Okay, so we are going to shade above. So far my region is all this area here. Fourth inequality, y is greater than or equal to x minus 2. So intersection at negative 2. I'll do this in the blue, in the purple. Yeah, let's do it in red. I haven't done red yet. There you go. Slope is 1. So up 1 over 1. Okay. And again, so this line looks like this. Point of intersection here is going to be at 3, 1. And we want to be greater than that. So 0 is greater than -2, so we're shading this area. So here is our region. Now, we do have a couple points. If we want to find the boundary points in that region, 3, 5 is one of them. 3, 1 is another point. I don't know this point of intersection yet. I'm going to have to find that one. This point of intersection also is a little bit tricky, but it's not too bad because it's at a half, so I can pretty much tell this is going to be -1, 2, 2.5, 5. Okay? Because the slope is 2, that means if I go up 2 over 1, slope of -2, so if it's up 1, it's over a half, right? So that's not too hard to figure out. This point of intersection, we are going to have to find where this point of intersection is. But again, that's just a matter of saying, okay, y plus 2x equals 0, and y equals x minus 2. We do substitution here. So x minus 2 plus 2x equals 0. So it's going to be 3x minus 2 equals 0. So 3x equals 2, so x equals 2/3. So if x equals 2/3, y equals x minus 2, 2/3 minus 2. So 2/3 minus 2 is -4/3. So that's that point of intersection right there. So those are the 4 points of intersection for my region. 1, 2, 3, 4. And then I substitute each of those values into my function here. So my points are 3, 5, -2, -5/2, 5, 3, 1, and 2/3, -4/3. I'm going to plug each of those points into this equation, 5x plus 3y. I'll find out which one gives me the maximum value, which one gives me the minimum value. If I actually go ahead and do that, 3, 5, that'd be 5 times, it's 15 plus 15. So f of 3, 5 is 15 plus 15, or 30. F of 3, 1, that would be 15 plus 3, which is 18. F of -5/2, 5, would be -25/2 plus 15. So -12.5 plus 15 is 2.5. And f of 2/3, -4/3. Well, that's going to get fun. 5 times 2/3 plus 3 times -4/3. 10/3 minus 12/3 is -2/3. So the maximum value, this is my maximum right here. That's my max. And this is my minimum for that function. And if we got into linear programming, we might create scenarios that these lines may represent actual data, and then that function would have meaning. But we aren't really concerned about that right now. It's really just the exercise of graphing and finding the points of intersection and that sort of thing. So that's kind of what we're doing today. Now, yeah, every point didn't come out to a nice, neat point. This one, the -2.5, 5, was pretty easy to find. This one required me to take my two equations and do some substitution or elimination or something to find that point of intersection. Because that point of intersection wound up being important. So we had to use some of our techniques from last night in order to do that. But it's definitely not horrible. I mean, 2/3 negative 4/3 isn't beautiful, but it's not the worst point in the world. And some of them are really simple. And that's the kind of thing that we're doing. We're just graphing multiple lines and finding the points of intersection. Now, that's a complicated example. Okay? That's one of the harder level problem examples. Most of them are pretty easy. In fact, almost all of them have pretty easy points of intersection in most cases. But that's the kind of thing that we're doing today. This is probably more complicated than almost anything that's in the homework. Should we do one more example? No? Please save me. Don't ever do an example like that again? Okay, fine. I'll let you do a kind of homework then. Nice quiet day. Okay, fine. So here we are on February 4th as people are dying in here, it sounds like. So it looks like we got 6 of these to do, 11 through 16. You know what, though? I'm going to be nice today. Let's do 11 and 12. Those are really simple. So we can just skip. We can just do one of those. Let's do 12 through 15 instead. Let's cut it back to 12 through 15. How about that? Instead of 11 through 16, 12 through 15. So we'll only have 4 of them. And there's graph paper in back. If you already started on number 11, you can skip number 12 then. Okay? Just 12 through 15. We're cutting her back. But don't forget, we're going to spend the first half of tomorrow, guys. Hey, listen up. No surprises. First half of tomorrow, first like 10 minutes or so, we'll spend just going over things and asking questions. Then we're going to take a quick quiz on just these 2 things, graphing linear equations, graphing linear inequalities. It'll be like a 1-page, front side only type quiz. Just graphing, pretty much. It's going to be short, but it's going to be, that's what we're going to do on Chapter 2. Then we'll dive right into Chapter 3 by Thursday. So that means everybody needs to have this homework done tomorrow. All right?